Hello everyone, welcome back to our course Deep Learning with TensorFlow and Keras. We already talked about deep learning, how we can implement our model for the classification, and we saw an example on MNIST data, and we loaded from a library, so we didn't do anything. But for your purposes, you first should call or read your data and then feed it to the model. So for this purpose, we have two approaches. So one is read your data directly from a folder that they are saved, and or call them from a CSV file. This is two the common or general approaches that are used for reading the data and make them ready for feeding to a network. So I will show both of them to you, and we will implement a script to read them and make them ready for a network. So assume that we have data like this, for example, for the train or for the test, and we have some classes. For example, in this case, we wanted to do the classification of plants and weeds. So it's such a binary classification. So we have some images of plants, as you can see here. There are patches of plants. So, and we have some images or parts of weeds. If you, for example, see here, there is a weeds in middle of plants, or you can see, for example, here, and as well here on images. On any image, you will see that, okay, in between each plants there we have some weeds, and we wanted to recognize or do the classification on these to separate weeds from plants. So we have them in this directory or in this path, okay? And first we want to just directly read them from a path. So if we go to our script, so we should import some libraries such as NumPy that we wanted to do this, such as Matplotlib if we wanted to show some of the image, or OS or a CV2. In this approach, we need this OpenCV library. It means that you should install or import import the OpenCV to read or modify your images. So and other libraries that I will talk about them. For example, random to make a shuffle on your image, pickle to save your image after reading them. So I will talk about these libraries. So first of all, we should give a path or a directory of images to that. For example, I said that, okay, I want to read the data train, okay, as we saw, and we will define the classes that we have. For example, here we have two classes of plants and weeds. So we wrote plants and weeds, okay. So we define a variable for the training data. We define an image size if we know the images, if all of them are at the same size. Even we don't need some but if you know that some of them are not are in different sizes, we can use the same size for all of them, because when we want to feed it to the network, all images should be at the same size. So we define a function. We can call it create training data, and we will write a loop for the category inside that goes inside the whole category of our classes. So in do we make a path for that. That is the data directory and the category that we have. So we have the data directory here, and then the category, for example, plants, to go for plants. Let me to run it one by one. So, and then we get the classification for this, for the categorial. We will assign a class number. So you know that, for example, if you want to make it as a label, so we should have, for example, for plant 0, 1, or for the weeds 1, 0, or vice versa. So this is the label for them, and we will define it here. And therefore, we can write a loop to go to the folder, to go to our folders and read one image, image one by one. So it goes to the directory. And then we can use cv2.imread to read our images in the path that we gave here, and we define it that it is the grayscale. So we know that it's the grayscale, and we define it here. And then for the training data, we join the images and its class together in our database, training database. So, and then when we do this, so we can also write this line if you are interested to keep your output clean. But if you don't write it, it can also work. But also you should remove try here. So, and then we call our function create training data. So if we run this, it will go to our database and we read all of our images. So 100%. So we have three, if you can see here, 3,292, and it read all of them. And for the another category that can be a wheat, it had 3,138 images. So in total, we have 6,430 images. So, but when we wanted to send it to our model or network, it's not good to have them in a row. So, for example, all the plants and then all the image of weeds. So it means that, for example, for the first batch, if you consider, for example, batch of 100, all the images that will go to our network are plants image. So our network are designed or adjusted based on the plants. So it's not good. So it's good to make it shuffle. So, and then after this, we can prepare it and choose a batch size for feeding our network. So for this, we can shuffle it with the random.shuffle for the training data. If we wanted to see how it's shuffle it, we can, for example, print the label of the first 10 samples. So we see that, okay, the first 3 are from one class, and then from another class, again 3 from another class. If we repeat it again, we see that it's changed. So the 3 comes from the class of 1, and the fourth one comes from the label of 2, the class of 2 or 0. So if we do this several times, it's shuffled in a random way. So we shuffle the data, and then we define, okay, X and Y, that is the data and the label for them. So we can again write a loop to go from the features and the labels for the training data. And then we save the features in X and save the labels. The features are all the data or images at that, and then label for Y. We will save it on Y. And then, as you know, for the class, we have to do some reshaping to put all the image, all matrix of images together in one variable. So for this, we use the reshaping of image size, and the last one is the depth of this. It can be 3. And then your data are ready for feeding to the. We have the x, like the x train in our example, and the y, like y train in our previous example, or y test or x test from our previous example. So you can do this at this just 4 blocks at the beginning of your code instead of loading mnis, and do the classification or other task that you want. But I recommend you to save these matrices or this data that you call it, and the next time just load this file, pickle file we call it, instead of going again to the folder, read each image one by one and so on. So it saves a lot of time for you. So to do this, we can import, as I saw in the middle, we can import a pickle library and just write open x validation or x train. It can be, for example, train, as we call the train, and also y train. Dot pickle, and we give the permission of write, and so then we can say that, okay, save the x in the pickle out. This is the function that the variable that we define here, and then close it. And for the label also we do this. We do the same in another pickle file, y train, and we save it on our system. So if I run it, so for this and reshaping, and then save on pickle one. So if we back to the folder that I had, you see we will see here 2 files, x pickle and y pickle, x train.pickle and y train.pickle, that is corresponding to our data. So next time, instead of reading all image, you just need to call these 2 files, and it loads all your data to feed on a model. So you can do this for the also testing data. We did it for the data train. We can use it for the data test and save it on the, for example, x test.pickle, y test.pickle, and so on. And if you also have the validation data, you can do this for your validation as well. So this is one of the approach that we can use. Another approach is the time that you have a CSV file. For example, if I back, you have a CSV file of train and the test, and or even it can be validation, and you have the file name here, the name of your images, and the label of them. So it's 0, and if you go for another class, you can see it, okay, this is the label is 1. We have 2 classes again, or in this example, maybe I have 3. Yeah, I have 3 classes here. So we can do the classification on 3 classes. So for this, we can read our data from the CSV file. So we need some library similar to the previous one. In this case, you even don't need OpenCV, and you can just use SCIP for reading the data. So you will almost import the same library as before, matplotlib and so on. So first, you should use the read CSV from the PD that is you. In this case, also I forgot to say it. Excuse me. You also need to import the Panda library. So by the Panda library, you read your CSV file. It can be train, it can be test, or both of them, and save it on a variable, and then you can choose from the you should first read the header of them. That was if you remember. Let me to show you again. We had on the header, we had the file name and label. Okay, it's defined. So if we are back here, we can see we should have the train and the file path or the directory of the image that we defined it on the Excel on the CSV file as well. And then making a for loop to go to the CSV and read the path of each image and the label of that, like this. It goes to the path. It read the images from its path, and then change the type of that, and go on. And if you want, you can do normalization. For the previous example, you can also do the normalization. It's just divided by 255 if you want. And then, as I said, for the cross, we should do the reshape. The X shape, it can be any size. It can be any size. And then one, that is the depth. And you can repeat it for test data. We did it for example, we just read the image name on the training data. And we can do this for the repeat it for the test data, exactly the same codes that we use. And then reading the labels for your data from the CSV file. So from the class, it will be categorical. You will read the labels for the train, and you will read the labels for the test or validation dataset. If you want, you can split it on different category. For example, train and validation, or train and test, or validation and test. At any format that you wanted to, for example, split your data. But if you have for each category, train, validation, and the testing, if you have image for each one, you don't need to split it. But if you want to split your training data into the train and validation, you can use the split function here to split it, for example, by 0.3, so 70% on the training, 30% on the validation or testing, and so on. So the same, you can, the code here, another approach, you can just save it on the pickle file, like this, and just for the next time read the pickle file, or even add these plugs to your code. So, and also, as the last point that I wanted to mention here, in our example, deep learning example, we use the tensor board to make a visualization on of the curves of the laws and validation. But if you don't want to use tensor board, so I personally, in parentheses, suggest to use the tensor board. But if you don't like to use it, and you wanted to make a graph and save it on your system, you can just use the matplotlib and make a figure, and then from your model, save the accuracy and validation accuracy, and define a title for that accuracy, the number of epoch for the X label, for the legend. We can use the train and test because we have two curves of the train and test, or train and the validation, and save it with the name. And again for the loss, because it was for the accuracy. And for the loss, you can also do the same and save it on your system with the matplotlib and show it even on your code. So these are approaches, two common approaches that you can use for reading the data. And you also know already how you can define or implement a model for the classification on TensorFlow and Keras. In general, if you know the concept of this, you can use any platform such as TensorFlow, PyTorch, or I can say that Tiano, or other platform of deep learning, and just implement this. And I think by these videos, you already know how you can implement these models and how you can read your own data to, or own data to feed it to the network. Thank you for your watching. Have a great time. Bye.